So in this video, we'll be looking at the main algebraic tools that you can use, like substitution, factoring and canceling, rationalization, in order to evaluate some limits. So these are just different methods of algebraic manipulation that we can use in order to evaluate the value of a limit. So first and foremost, whenever you're given a limit, you're going to want to start with the simplest method, and that's going to be direct substitution. So looking at this limit, let's say we're trying to find the limit as x approaches 2 of the function 3x squared minus 5x plus 1. So let's try to use direct substitution in order to evaluate this limit. And so when I say direct substitution, what that means is you're going to want to take the value that this limit is approaching. So in this case, 2. And you're going to plug it in to this function everywhere we see x. So for every x value, or x that we see in our function, we're going to plug in the value that the limit is approaching. So that leaves us with 3 times 2 squared minus 5 times 2 plus 1. Or 12 minus 10 plus 1, which is equal to 3. So this is then going to be our answer. So this is the limit. So the limit as x approaches 2 of our function 3x squared minus 5x plus 1 is going to be equal to 3. So it's very straightforward. And so the trick here is that polynomials and most of these other continuous functions are going to behave rather nicely in that we can just use direct substitution. So let's say for another example, what if we're trying to find the limit as x approaches 2 of 4? What is this? We don't really see any x's going on here, right? So what is the limit as x approaches 2 of 4? If you want to take a minute, think about what this function means, and then you can, unpause and you can see what the solution is. All right. Well, we know that, what is this function representing here? We just have 4. Well, the graph of this function, if we were to try to draw this graph out, well, it would just be a horizontal line at 4. And pretend this goes through 4. So it's just one straight horizontal line going through the value of 4, and this just continues. And so if we're approaching the value of 2 or 3 or any other number, we're going to see that the y value is going to remain 4 at all times. And so if we wanted to find the limit of this function by direct substitution or any other means, it's simply just going to be equal to 4. So it's very, very simple if you're just given a function like this. All right, but now what if you're given a case where, sometimes the substitution doesn't work? Like what if we're given, we end up with a substitution where we get something like 0 over 0, right? That doesn't actually mean necessarily that the limit doesn't exist. It just means that we need to try a different method to further simplify the function. So let's say that we're given a function like this where we kind of see this happening. So what is the limit as x approaches 3 of x squared minus 9 over x minus 3. We can see that if we tried direct substitution, we would get 3 squared minus 9 over 3 minus 3, right? And this is going to give us 3 squared is 9, so 9 minus 9 is 0 over 0. This is what we just talked about. And what this is actually called is, this is known as an indeterminate form. The indeterminate form. So if we're given this indeterminate form, it means that, we can move away from substitution, and let's try the next method in our, in our toolkit here. And what that next method is going to be is what is called is just factor and cancel. So that is we're doing really what the name is suggesting here. So in factor and cancel, we're going to factor the function that we are given and see which components of that function then can cancel out, and then we just employ direct substitution with whatever is remaining there. So we're told again that our function is x squared minus 9 over x minus 3. So we can see that this function, this numerator, can be simplified by factoring it out, right? We know we can factor x squared minus 9. This difference of squares is simply going to give us x plus 3 times x minus 3. and we still have this x minus 3 in our denominator. And so this allows us to cancel out our x minus 3 from the numerator and denominators, leaving us with x plus 3. And so now, if we employ our direct substitution here, we can see that we end up getting 3 plus 3, or 6. No longer an indeterminate, but we get an actual real value here for our limit. So oftentimes for your AP Chem, for your AP Calc, right, AB or BC, and also for most introductory college classes, with calculus, what they're trying to test you is if you're able to recognize these patterns. So oftentimes when you see something like this, they're just trying to see if you know, hey, does he know when you should be trying to factor and cancel versus substitute? So they're often not going to be too complicated, too crazy. So if you see something like this x minus 3 in the denominator, most times it's kind of a safe bet that the numerator is going to have factor out into something that also has an x minus 3. So it's going to be x minus 3 times something over x minus 3. So oftentimes you want to try this out, writing it out like this, and to see what you would have to multiply in order to get to the other part. In general, it is kind of a safe bet that you'll end up getting something where if the denominator has this sort of expression, that's also going to be in the numerator. Because they wanted to see that you're just testing you on your abilities to use these skills, not just to stump you necessarily. So the main trick here is, again, when you get a 0 out of 0, this sort of indeterminate form with a polynomial, move away from substitution and try factoring. Now the next tool in our arsenal here with finding limits is going to be something called rationalizing. So rationalizing. And this is going to be something that you're going to have to try to use oftentimes when you end up getting, or a limit where the function has a square root. So let's say we're finding the limit as x approaches 0 of the function x plus 1 minus 1 over x. So in this case, if we wanted to start off, as always, with direct substitution, we can see that if we plug in a 0 here, that's the square root of 1, which is 1. 1 minus 1 is 0, and plugging in 0 into the denominator for x also gives us 0. So we end up with this indeterminate form. So we can't use direct substitution. Okay, but now what you'll want to use, or what you'll want to do really, is if you see a function that has this sort of expression in the numerator or on the denominator with a square root, rationalization or rationalizing is probably going to be your best bet. So what that means is you're going to want to multiply the numerator and the denominator by the conjugate. So what is a conjugate then? The conjugate of some sort of a binomial, right, with a square root or any other irrational term here is just going to be that same expression, but with the opposite sign in between. So let's say that our expression was a plus the square root of b. The conjugate of this would then just be a minus the square root of b. And vice versa, right? If we had a minus the square root of b, the conjugate would be a plus the square root of b. So it's nothing complicated, nothing super crazy. And why do we do this, right? Why do we use the conjugate in limits? Because when we're finding the limit, you're often going to get that indeterminate form, 0 over 0. And so this is especially going to happen when we have square roots that are involved. And that's just the nature of the way the functions look. If you even look at a graph with a square root, if you graph this function, it would just kind of make sense as to why we're getting an indeterminate. But basically, what we're doing here in this case is by multiplying the numerator and denominator by the conjugate, it rationalizes the expression, which means that it's going to remove that square root in the numerator, or if it was in the denominator, it's going to remove the square root in the denominator. And this works because that property of differences of squares. We know the differences of squares formula, right? We know that a plus b times a minus b is going to be a squared minus b squared. So kind of taking advantage of this differences of squares formula, we're able to get rid of this square root, which is going to make things a lot easier down the road. So let's try this problem then using rationalization. So what do? We start off by multiplying the numerator and denominator by the conjugate. So the conjugate here is going to be x plus 1 plus 1. So again, we do that in the denominator as well. Plus 1, plus 1. So doing this, we can then simplify this expression, right? We know that we're doing a minus b plus times a plus b. This differences of squares. is then going to give us a, here, let me actually do this, equal to, if you wanted to see again, this is just a, not a minus b, this is just a minus b times a plus b. So then we're going to just end up with a squared minus b squared. So if this is our a term and this is our b term, a squared minus b squared is simply going to be x plus 1 minus 1 squared, which is just 1. And in our denominator, we're going to end up with x times the square root of x plus 1 plus 1. Simplifying this, we end up with x over x times the square root of x plus 1 plus 1, allowing us to then cancel out our x from the numerator and the denominator. And if we just clear up some room here, we can see that then just leaves us with the expression 1 over square root of x plus 1 plus 1. And for this value, or for this function that remains, if we try direct substitution, we can see that we end up with 1 over the square root of 0 plus 1 plus 1, or 1 over 2. So now we no longer have an indeterminate form, but we have we've been able to simplify this using this tool of rationalization, and we ended up with a value for our limit of 1/2. All right, so that brings us to the end of this video. The main point of this video was just to introduce you to the different tools that we can use in order to evaluate the value of a limit if we're not able to, if we don't have access to a graph, for example, right? And so these are just some of the tools that are very commonly used. And in the next video, which, keep an eye out for, I'll just be going through a number of different examples. So feel free to follow along just to get more practice in that video. But in any case, if you did find some utility from this video, please show your support by liking and subscribing. Leave in the comments what you'd like to see next or any questions you may have, and I'll see you in the next video.